Hi guys, today we're going to look over the properties for a rhombus and for a square. So we're going to start on page 16 of the chapter 8 notes, and we're going to go over a couple things on here. So the first thing is that you'll notice the first couple properties all belong to a parallelogram. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. The diagonals bisect each other. So here's some new things. We have that the diagonals are perpendicular. That means that in the middle, where they intersect each other, they're going to form right angles. So that's going to be important. We're going to see a lot of questions based on that. Okay, the diagonals bisect the angles. That means that these little angles in each corner, each side of those angles is going to be equal to each other. All four sides are congruent. So that's definitely different than the rectangle and the parallelogram. Okay, and something important here, the diagonals are not congruent. Okay, so that's going to be important. They are not congruent. And you could probably tell that just by looking at the shape of the rhombus. So for the square is probably the one that we know the most properties about. All the properties for a parallelogram are going to be true for a square. So the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary. The diagonals bisect each other. That means the parts of each of the diagonals are equal. The diagonals are congruent in a square. Okay. All four corners are 90 degrees. So this is some of the stuff that we've seen in a rectangle as well. Okay. The diagonals are perpendicular, meaning that they form right angles just like the rhombus. Okay, and the diagonals bisect the angles, meaning each of these little angles here is going to be 45 degrees. Since we know each corner is 90 degrees, each corner angle, that means that when we have a diagonal, each part of that is going to be 45 degrees. So if we go to the next page, we're going to start by going over some examples with the square. Okay, all of these notes should be copied down into your notes as well. So I'm going to start with the first one, and all I'm going to do here is I'm just going to copy the information. So if AB equals 2x plus 4 and CD equals 3x minus 5, find BC and find BD. So we'll worry about that later. What we're going to think about right now is what we know about these two things that we have labeled. So first thing I'm going to say to myself is, what are these? Are these angles? Are these diagonals? Are they sides? Okay, so these are sides, and we know that the sides of a square are all congruent. So these two are going to equal each other. So 2x plus 4 equals 3x minus 5. So first step to solving here is we're going to subtract 2x from both sides, and then we're going to add 5 to both sides. So x is equal to 9. Now, it doesn't ask us specifically for x. What it does ask us for is what is BC. So since we know all the sides are the same, I can plug back into any of these. Right? So I'm going to plug back into AB. 2 times 9 is 18, plus 4 is 22. So BC is going to be 22 as well. All the sides are going to be the same. 22, 22, 22, and 22. Now, the next thing that it says is find BD. And BD is this diagonal that I just highlighted in blue. So there's a couple things that I know here. The first thing I know is that this angle at A is 90 degrees. If you look, this is a triangle. ADB is a triangle. So I have a 90-degree angle, and I know each of these is 45. So even if I redrew it for you so that you could see it a little better, 45, 45, 90. We know that each of the legs are 22. Okay, and that means that we have to find the hypotenuse. So remember, the hypotenuse is equal to the leg times radical 2. So it would be 22 radical 2. And that would be what BD is. 22 radical 2. If we go on to the next one, find the measure of angle AEB. So I'm going to highlight that in red on my photo. Okay, and we know that because the diagonals are perpendicular, in the middle there where the diagonals intersect is going to be equal to 90 degrees. So if that angle is 3x and it's equal to 90 degrees, that means that x is going to be equal to 30 degrees. Next, if BAC equals 9x, find x. So BAC is going to be starting at that upper right-hand corner, going to A, and then going all the way across to C. I'm highlighting it in green. Okay, and because it is half of that right angle, we know that the diagonals bisect that right angle. So that means each half of that right angle is 45 degrees. So when we divide each side by 9, x is going to be 5. Lastly, the perimeter of the square is 32 centimeters. Find the length of diagonal DB. So they're giving you something else here. So if we have the perimeter is 32, and we know all the sides are the same, that means each side is going to be 8. And it says find the diagonal. DB. Okay, so again, we know that this is a 45, 45, 90. So if my legs are each 8, then my hypotenuse, which is the diagonal, has to be 8 radical 2. Now, if you notice here, some of those we've actually done before when we did all the shortcuts for 30, 60, 90, and 45, 45, 90. All right, and then the last page we're going to do is the rhombus page. So for the rhombus, let's look at what we have here. DM equals 6y plus 4. ML equals 5y plus 8. Find the length of KL. So they just want you to pretty much find a side. So we know that the rhombus, the sides are the same, just like they are in a square. So if I subtract 5y here, and I subtract 4, we get y equals 4. Now we can plug back in for any of them since we know that they're all the same. So 6 times 4 is 24, plus 4 is 28. Okay, so if one side is 28, they're all 28. So that means KL is going to be 28. Let's go down to the second question. Find each variable in the rhombus. So sometimes for something like this, we gotta look at what we have. The first thing I see is I got these sides, and I know that the sides are congruent. So I'm gonna start with that. So if 4x minus 4 is equal to 24, because those sides are congruent, after I add 4 to each side and divide, we know that x is equal to 7. Okay. Now, it also wants us to find the measure of each angle. So there's a couple things that we know here. Some of them are things we learned with the parallelogram, and some of them are specific for a rhombus. So I know measure A is going to be 37 because the 37 and the A are opposites. I also know that my diagonals, when they intersect, they're perpendicular, so all those angles in the middle are going to be 90 degrees. Okay, so that takes care of A and C. Now I might have to do a little work for B and D. So let's see what else we know here. We know that for a rhombus, when the diagonals hit these angles in the corners, okay, if they bisect it. So that means if one side is 37, the other side has to be 37 as well. Okay. So the last thing that I could do here is I got to find out like D or B. So if we look right here, we know that, let me put it in a different color, sorry, if I put it in red, this is a triangle. So if I have a 90-degree angle, and I have a 37-degree angle. If I subtract those from 180, that leaves me 53 degrees for the rest of this triangle. So if D is 53 degrees, then B, which is opposite it, has to be 53 degrees as well. Okay, and that's the second question. Again, you can always pause this if you need. Next, for the rhombus, find the measure of the numbered angles. Okay, again, for a rhombus, we know that when the diagonals intersect, they form 90-degree angles. So angle 2 is going to be 90 degrees. Okay. We also know that the diagonals bisect the angles. So if this bottom angle is 58, the other part of it also has to be 58. Okay. Since 3 is opposite that 58, 3 is going to be 58 as well. Now, the last thing here is I have to find 1 and 4. So if I highlight, I'm going to highlight this triangle in blue. Okay, this should look just like the last one. We know that a triangle is 180 degrees. So if I subtract 90 and 58 from 180, I'm going to get 32 degrees left for that last angle. So that means 4 is 32 degrees. And once again, since those diagonals bisect the angles, if 4 is 32 degrees, then the other part of it has to be 32 degrees as well. Last question. The diagonals of a rhombus are 10 and 24. Find the length of the side of a rhombus. So this is 10, and this is going to be 24. Now remember, it's the whole diagonal. So, best way that we could do this is we know we have lots of triangles here. Okay, we know that those diagonals are perpendicular, so in the center are going to be all 90-degree angles. The other things that we know is that the diagonals bisect each other, therefore they split the diagonal in half. So if 10 is split in half, one side is 5 and the other side is 5. And if 24 is split in half, one side is 12 and the other side is 12. Now, that makes it a little bit easier for us, okay? Because we know that this across from our right angle, that side is our hypotenuse. Okay, now we don't know the angles at the bottom, so we can't necessarily use our shortcuts. But what we could do is we could use the Pythagorean theorem because we have the measure of two sides. So 5 squared plus 12 squared. Remember, your hypotenuse always has to go in C. Okay, if we multiply this out, 5 squared is 25. 12 squared is 144 equals C squared. So when I add them together and take the square root, I get C is equal to 13. Okay, they do use the units centimeters, so I'm going to put that underneath. Sorry, centimeters. Okay, now the other thing is, if you notice here, this is a 5, 12, 13 triple. Okay, so you could also have noticed that as well. All right, so those are the rules for your rhombus. All right, you guys just have to submit the notes and you are done with the homework. Have a great day, guys.